Welcome to the session number 21 from the playlist of Work, Power and Energy. The topic is the spring block problems, and this is the first question from the category of this spring block questions. And this question is available in the NCERT book, so you all can access it. And the question here is that a block of 1 kg is connected to a spring on a rough inclined plane. So this is a block of 1 kg which is connected to this spring on a rough inclined plane. This is the inclined plane, and the block is released from the rest in the unstressed position of the spring if the block comes down 10 centimeter down the plane. So if this block, when the block is released, this block comes down down along the plane, and it comes down by 10 centimeter. So if the spring constant is equal to 100 newtons per meter, then we have to find the coefficient of friction between the block and the inclined plane. So here, since the surface is rough, and since the force of the friction opposes the relative motion, and because this block is coming down along the plane downward, therefore the force of the friction, say Fs, will be acting in the opposite direction, that is, it will be acting along the plane in the upward direction. Now the weight of this block will be acting vertically downward like this, that is mg. So this weight, I am just resolving the this weight into two components, that is, one is the horizontal component, or you can say the component which is parallel to this inclined plane, and the other one is perpendicular to this inclined plane. So this is the component which is perpendicular to this inclined plane, and so this is equal to mg cos 37 degree, because here 37 degree is the angle of inclination of the plane with the horizontal, and this horizontal component will be equal to mg sine 37 degree. So now if the block is coming down, it means that mg sine 37 will be greater than the force of the friction which is acting in the upward direction. Now the force of the friction is equal to mu into normal reaction. So the normal reaction is equal to, will be equal to, here this is the normal reaction. The normal reaction always acts perpendicular to the surface. So this is the normal reaction, and this will be equal to mg cos 37. So if the block is coming down, it means that mg sine 35 is greater than the force of the friction, which will be equal to mu n, or you can say which will be, or we can say that Fs, that is the force of friction, will be equal to mu mg cos 37. Okay? So so the net force which is acting on this block in the downward direction will be equal to mg sine 37 minus mu mg cos 37. So this is the net force which is acting on the block. Now this block has got displaced by 10 centimeter down the plane. So the work done will be equal to, this will be equal to the net force multiplied by the displacement, that is mg sine 37 minus mu mg cos 37 cos 37 multiplied by the displacement, which is equal to 0.1. This is equal to 0.1 meter, because the block has got displaced by 10 centimeter. So in meters it will be equal to 0.1 meter. So the total work done will be equal to, this will be equal to, m is equal to 1 kg, and g is equal to 9.8 meter per second square in this question. So 1 into 9.8 into, now sine 37 is equal to 3 by 5, and so if sine 37 is equal to 3 by 5, then cos 37 is equal to 4 upon 5. Okay? So sine 37 is equal to 3 by 5, so I will be putting the value of sine 37 as 3 by 5 minus mu into 1 into 9.8 into cos 37 is equal to 4 by 5 and into 0.1. So this is the work done, and this work done will be in the equilibrium state. This work done will be stored in the form of potential energy of the spring. Now the potential energy of the spring is given by the potential energy of the spring is equal to 1 by 2 k x square, where x is the displacement of the block. So if I equate both these two equations, then I will be able to find the value of mu, that is the coefficient of friction. So here the work done is equal to, that is equal to 1 into 9.8 into 3 by 5. So I will be writing this as into 3 divided, 9.8 into 3 divided by 5. This is equal to 5. This is equal to 5.88 minus mu, and this is equal to 9.4 into 4. Sorry, 9.8 into 4. Divided by 5. So this is equal to 7.84. So this is equal to mu into 7.84, and this is multiplied by 0.1, and this is equal to half k x square, and k is equal to 100 Newton per meter into x square, which is equal to 0.1 whole square. So this is the equation which I have got, and by solving this equation we will be able to find the coefficient of friction between the inclined plane and this block of 1 kg. So from here this 0.1 and 0.1 will get cancelled out, and from here now I am getting 5.88 minus 7.84 mu is multiplied by 2. This 2 I will be just cross multiplying this equation on both the sides. So by cross multiplication, this is equal to 100 into 0.1. So now 5, this is equal to 5.88 into 2. This is equal to 11.76 minus 7.84 into 2. This is equal to 15.68. 15.68 mu, and this is equal to 10. So from this I am getting 15.68 mu is equal to 11.76 minus 10. So this is equal to 1.76. 11.76 minus 10 is equal to 1.76. So mu is equal to 1.76 divided by 15.68. So this is equal to 1.76 divided by 15.68. This is equal to 0.11. 0.11. 0.11, yes. So the coefficient of friction is equal to 0.11, that is the coefficient of friction between this block and the inclined surface is equal to 0.11. So here the most important thing was that the work done in the stable this, or you can say in the equilibrium state, the work done will be stored in the form of potential energy of the spring. And so the first of all, what we have done is we have calculated the work done due to the forces acting on this block, and then we have equated it to the potential energy which is stored in the spring. So by equating the potential energy of the spring and the work done, we were able to find the value of the coefficient of friction, which is equal to 0.11. So thank you very much for joining this session. In the next session, I will be coming up with a different type of a question from the same topic, that is the spring block problems. So till then, have a nice day. Bye.